A very good day to Doctor. My name is Diana Ganifan, AE190077. Today I'm going to do a presentation on exercise 4 LVSP system operations BEV30401. Okay. According to the stated activity 1, that we are going to perform 3 procedure of LVSP systems, which consists of turn on the MSP system, bus bar coupling of MSP1 and MSP2, normal supply restore. Okay, based on the video given by the lectures in electrical lab, power engineering lab, so I'm going to define that the turn on the MSP systems have 7 steps. Well, first we need to make sure that our load MSP1 and 2 are off conditions. Then the LVSP also required to in off conditions. Okay. Next, we are going to turn on the incoming supply from a transformer or isolator, then check the main supply and the LVSP. Well, this is to connect the power circuit breaker ACB. So we also need to make sure the ACB is in isolated condition with its off status. Thirdly, we are going to take out a charge handler for the compartment inside the ACB and set it to the slot. So we can turn the handle clockwise and change the status to the on conditions, which means that the ICB current is then connected to the bus bar. Then the bus bar will have the light indicator, which consists of a red, yellow, and a blue. They will light up when there's a current flow. Okay. Well, before that, we turn on the switch on the AC circuit breaker. We are going to charge the coil first. We're going to do it manually, so we're going to pull down up and down for the charge handle. Look at the side of the coil charging at the MSP there, MSP1. So then we are going to see that if the charge of the coil is activated or energized, then we're going to switch on the ACB. Okay. So when the ACB is switched on, the light will light up. After that, we're going to switch on the MCCB to give a power supply to the consumer unit. So I'm going to inform the consumer unit there because the consumer load is over there, so we connect the supply to the consumer load. So for the MCB2, we just repeat step 1 and step 6. Now for the bus bar coupling, MSP1 and 2, well, it's like doing a maintenance in the MSP1 and off 2. So we make sure the load in MSP1 and 2 are off, and the current status is 0 ampere, so there's no current flow. So now we can turn on the ACB air circuit breaker. Press the red button, and a bus bar light indicator of a red, yellow, and blue will be turned off and de-energized. And after that, we're going to do it turn off all the power supply in MSP1 and 2. So we take out the charging handle, and we're going to insert it and add it and turn it into anti-clockwise to change it to the off and isolated status. So after all the procedure steps 4, 5, 6, 7 is done. So this is the maintenance process, which is going to safely coupling for the MSP1 and 2. So we're going to switch off all the things and reconnect it again. After this process, we're going to use it in a normal supply restore. Okay. So like I've said, we're going to turn off first in order to check all the equipment, and then we're going to turn on the isolator C1 and MSP1, check the bus bar, and all the key need to remove and place it back to the MSP1 and 2, the key need to place it back to the original place, and then we're going to remove the ACB key and slot it back to the ACB. And then we're going to use the charge handler to charge it back for the clockwise side. We'll make sure that everything is flow for the bus bar. The charging indicator will light up, and we're going to turn on the ACB. So After that, if the bus bar is light out, normally we will turn on the consuming unit switch manually. After all the process, coupling, maintenance, and switch on and off process, we need to jot down the logbook. So that's it for presentation. Thank you.
My name is Brandon Dennis Chalanchun, matrix number AE190103. I will be explaining the function of the 4-pole isolator. So the 4-pole isolator has 3 poles used as an isolator and 1 neutral pole. This type of isolator is used by connecting an electrical component rated 230 volt AC single phase. So the function of the 4-pole isolator is to protect the component from short circuit when overload occurs. So whenever numerous generators are employed, all of the transfer switches that provide 3-phase and 4-wire loads must be the same 4-pole isolator.
Hi and Assalamualaikum. My name is Elia Adila binti Nasaruddin. My matrix number AE190074. Okay, so I will continue for the next question, which is question number 2. Okay, so briefly explain the function of essential switchboard, which is ESB. Okay, so ESB is an essential switchboard that used for power distribution, electrical protection, and monitoring. Then, main role of the switchboard is take the incoming electrical power from the main supply source and distribute power to appropriate circuits within the buildings. Therefore, the switchboard had performed the function electrical protection against damaging effect of fault. Then, the switchboard also used to monitor the electricity status and quality of the input power. And the last one is question 4. Briefly explain the function of automatic mean failure board, which is AMF. So AMF is automatic means failure panels, often referred to as automatic transfer switch (ATS) panels. Make the power switch to emergency standby generators in the event of a significant loss of main power or total blackout. Without AMF panels, generators need to be operated manually, and that can mean lost data, potential damage to electrical equipment, and also huge amount of disruption. AMF also monitor the incoming AC main supply, activate the standby generator when mains power fails, and make an automatic electrical transfer of the building's load from the mains to the generating set. When the main supply returns, the AMF panels control a return to the main supply and shut down the generator after a suitable cooling run. AMF panels instantaneously activate the standby generator when main power fails, automatically transfer building loads from the main power supply to the backup generator after about a 15-second warm-up. When the main supply returns, the AMF panels controls the return to the main supply and shut down the generator after a suitable cooling run.